Hi all, this is lecture video series number 3. In this video we are going to see about term called correlation matrix. In this we are going to import Seaborn as SNS. We are going to use SNS head map will be defined as a corridor and annotation is true. So it is a correlation matrix where you are going to head map, but that head map is number you are going to top of the map, so it will have a deep correlations. So in this combination we will be having the annotation called true. Next we have feature engineering, that is we are going to have a flat values, that is instead of having dummy values, we are going to give the exact values nothing but df of a into df of b, that is thus df of a is nothing but you are going to have a df of new. In the new place of the values we are going to multiply this. We see a is nothing but your one plot array and B is another plot array. So one place of, for example, we will have x and y corners, in this B will be x and corners. So will df of pdf that get dummies nothing but in x and y corners the a of x and b of x will be multiplied, and a of y and b of y will be multiplied, and the data will be saved in d of f of get of p of get of dummies. So automatically this data will be saved. Next, we will be using the term called train test split. This train test split is nothing but you are going to selection of skeleton sklearn model in the form of selection import from the train test split, where we will be having the x train, y train, x test, y train and y test based upon the split of xy and test size equal to 0.2. So you will be having the will be xy coordinates, where xy coordinates we will be comparing to, for example, when we take one example of x equal to 1 and y equal to 2, there are 10 points between it. So we are going to split the 10 points in the form of 0.2 variable. So we will be getting 5 points. That's remember you are going to have a train test split. So it automatically splits the data from x equal to 1 to x equal to in the variance in the difference of 0. So it will take 1.2, 1.4, 1.6, 1.8 and 2. So we will be having 5 data values. So we will be automatically split. Next we will be having a term called linear regression. Linear regression will be having the formula sklearn model import for linear regression. So it will be importing the term called model. In this model we will be using the predefined function called linear regression. So it fits, for example we will be getting the x train and y train. So in the model it fits the values of x train and y train. So automatically this linear regression will be used in this model. Next, we have a term called model execution. In the model execution, we are going to predict the values that are, but in this we have predefined function that sklearn.metrics import mean squared error. So y prediction model predict of x test, we are going to print mean square errors in y test and y prediction. So it automatically gets the value. So it predicts based on the error test. Based on the error test, it predicts the value. Next, we will be having an important term from random forest classifier. For random forest classifier, we will be using the term called import random forest classifier from the skeleton.assemble. We are going to predefine skeleton assembly. We are going to use random forest classifier. In this random forest classifier, we will be using the term called CLF. It's number you are going to get the values of random forest classifier. So you are going to fit the given data in the form of x train and y train. So it automatically fits the data in the cliff. Next, we are going to use confusion matrix. The confusion matrix is number you will be using the term called y test. We will be using the CLF.predict. Based on the previous data values, you are going to use a confusion matrix. The confusion matrix consisting of a skeleton, that is for usage of confusion matrix, we will be using the predefined function called skeleton matrix. We are going to import a function called confusion matrix. That is, in this time we will be a predefined function called confusion matrix. From the for usage of this confusion matrix, we will be using that sklearn.metrics. From the sklearn.metrics, we will be using that called print confusion matrix y of test.clf.predict. So it predicts the value x, that is for a y of test it predicts the value of x of test. This predict of acceptance will be used in previous step from the random forest classifier. From the random forest classifier, it takes the value, so automatically it predicts it. That is, will be based on this, we will be getting confusion matrix. Thank you for watching this video. Thank you.